there are a few objectives over here, one of which is to check whether I marked you correctly. Okay, so question 1a, arranging numbers in ascending order. Please check your answers. You have to give the answers exactly as such. Okay, B1 over here refers to 1 mark. Okay? As long as your final answer is correct, you will get a 1 mark. No matter marks involved. That's what happens when you see a B1. So next, we have irrational numbers. They are numbers that cannot be expressed in a form A over B. In other words, numbers that include pi, numbers that include square root of prime numbers, cube root of prime numbers. All these will be irrational numbers. Okay, so out of all of them, we have 6 minus pi as an irrational number. So why is it that square root 16 is not irrational? It terminates, it is exactly 4. It is just another way of writing a rational number. Okay, 16 is not a prime number. We can square root it to get 4. Therefore, it doesn't belong under irrational number. Now for part B, part 2, I want a perfect square. Perfect squares are numbers that can be square root, which gives you a whole number. In this case, we've got square root 16. Square root 16 itself is a value of 4. This value of 4 is a perfect square. It is represented by 2 square. Okay, so 4 is a perfect square because it is 2 times 2. It is 2 square. And 4 is written as square root 16 in this case. Okay, this is the only perfect square in the list of numbers given. Any questions so far? Learn from your mistakes. Use your green pen and write down your corrections. Now part C, evaluate. When we tell you to evaluate, take out your calculator, start pressing numbers. 6 minus pi plus 1.203. Look at this dot on top. Is that a typo? Is that a piece of dirt on your paper? No, it is not. It is 0.203333. The more trees you have, the more accurate your answer, isn't it? But subsequently, they're going to ask you round off to 3 decimal places, which means that you better be working with more than 4 decimal places. So over here, we write down our value of 6 minus pi approximately with more decimal places, so that we will not have rounding problems. Now the next one, 1.20333. Have more trees. It's okay. Subsequently, when you add them up, you get approximately 4.061740. Now we see that we have many decimal places, and we only want to round off to 3 decimal places. So we only need to look at the fourth one. 1, 2, 3, 4. Look at this 7. Since it is greater than 4, in other words, it is 5 and above, we are going to round off the value 1 over here upwards. So we get 4.062. If you have a mistake over here, it is likely because you didn't work with enough decimal places in your previous steps. Learn from the mistake. For this question, please copy down the working as your correction. Otherwise, if you just copy the final answer and I ask you to do the question again, you may still not be able to do it. Okay, I think only one person got this correct. By writing each value correct to 2 significant figures, estimate the value. Each value. So I see there's a 198. 198 has a value. Okay, I'm going to round off the 198 to 2SF, which gives me 200. So this is an approximation sign. I've rounded off the first value to 2SF. Now the second value, square root of 99.75. We are supposed to round off the 99.75 to 2SF. That gives us 100. So this becomes 100. Not going to talk about the 3 yet. Let's talk about the 10.2. 10.2 is 3SF. Rounding up to 2SF, we get 10. And the last one, that's the killer over there. 3. The value 3. How many SF do you see? 1. What were the instructions? Each value, every single value, 2SF. So how do you change 3 to 2SF? 3.0. So because of this, quite a number of you lost 1 mark. So this one is marked as B210, which means that every error I minus 1 mark. So if you wrote 3 instead of 3.0, you minus 1 mark. If you have another mistake, you minus another 1 mark. Up to a maximum 2 marks. Okay, so the value over here will be 10. Next, question 3. Most of you got the negative 13 in some way or another through your own calculation. Negative 13, okay, fine. Whether it is drawing of a number line, whether it is doing calculation. But there were some careless mistakes. So many of you end up with negative 12. When you drew a number line, you end up with negative 12. You didn't count properly. Okay? So I'm not going to spend too much time on this. Take note of the presentation. It is very clear what this working is all about. So after 10 minutes, after 15 minutes, temperature went up by 10 degrees. Okay, so this is the difference in temperature. This is final minus initial. The final minus the initial, or you can look at it this way. Big number minus small number. Big minus the small. We get 10 degrees Celsius. Okay, and if we have an increase in 10 degrees Celsius every 15 minutes, for 1 degree Celsius increase, it will take 1.5 minutes. Logical so far? Or you can do it the other way around. Every 1 minute, temperature will go up by 2/3 degrees Celsius. I will also give you 1 mark for that. Either one of these, I will give you 1 mark. So over here, it will be every 1 minute, temperature increase by 2/3 degrees Celsius. This will also give you 1 mark. So the additional time taken is just your direct proportion. 4.5 minutes, 4.5 minutes. Whether you write it this way or 4.5, you will still get a final answer mark. If you have shown me every 1 minute, temperature go up by 2/3 degrees Celsius, or if you have shown me every 1 degree Celsius increase, it requires 1.5 minutes. If there is any marking error, any area that you feel that I should give you mark, circle with a green pen, write down the question number on the front page. Circle, write down question on the front page. Circle, write down question on the front page. Is it clear? Next, question 4. Samuel, this question got any problem? Got problem? Because Samuel was trying to key in, 11 to the power of 1010. Then his calculator say error. Then he think question got problem. So got problem, Samuel? No problem. You can do it right. Great. So now, for 4116, after you have written down 4116 in terms of prime factors, you will get 2 power 2 times 3 times 7 power 3. So you just compare. A is 2, C is 3. But what about this value of B? What is this value over here? Is it a 0? Is it 3 to the power of 0? No, what is it? 3 power 1. This over here is power 1. It's just that we don't write down power 1. So answer 2, 1, 3. To find the smallest positive p such that the cube root of 4116p is an integer. This tells me that 4116p is a perfect cube. Only if it is a perfect cube, then you can cube root it, right? And get a integer. So 4116p is a perfect cube. Now we have 4116 over here. So 4116p must be equal to 2 to the power of 2 times 3 times 7. What should the powers of all these prime numbers be? What is the prime number, the power for the factor 2? How many should we see? 3 of them. We should see 3 of them. How about the factor 3? What is the power? Again, it must be 3. It's a perfect cube. And for 7, what is the power? Again, it must be 3. Then we compare this with our 4116. What is the difference? The difference must be our p. So based on this, p is equal to 2 times 3 squared, which gives us 18. You cannot leave it as 2 times 3 squared, because they didn't say leave it in prime factors. They didn't say leave in index notation. Okay, next one. Hey, I remember I just went through this question just before your test. Yes, I did. 4116q is a multiple of x. So we find LCM of 4116 and x, which is equal to over here. This is the LCM of 4116 and x. Then from here you compare it with our 4116, yes? Okay, circle, write down question number in front. Take green pen, circle the question, write down the question at the front cover. Once we have the LCM of 4116 and x, we compare this with our 4116. So earlier on we said that 4116 is equal to 2 power 2 times 3 times 7 power 3. Compare. 2 power 2 is there already. Let's compare the 3's. Oh, 4116 only has 1 3. So what does that tell us about q? Another 2 of them. The next one, part B. Highest common factor, lowest common multiple of 480 and W, 10 and 2400. So likewise, we will need to write down our LCM and our HCF in terms of its prime factors. We will list down 480 and W. Now W, we don't know what is that yet. So we leave it as a blank. Okay, leave it as a blank. I don't know what this is. I don't know. But I do know that HCF is 2 times 5. Which means that both 480 and W have at least 1, 2, and 1, 5 as the prime factors. This is based on the HCF. And then based on the LCM, I know that one of them will have 2 power 5, 5 square, and 3. Okay, that's the maximum power that we can go. So we see W must have a 2 and a 5. Okay, I can fill in the blank already. W equals to 2 times 5. I don't know the powers yet. They can change. Let's take a look at the LCM. 2 power 5. one of them must have 2 power 5. Does 2 power 5 fall in under 480? Does 480 have a 2 power 5? Yes, have. So I don't need to give it to W anymore. Let's take a look at 5 power 2. Does our 480 have 5 power 2? Don't have. So I must give it to W. Last one is the number 3. The prime factor 3. Does it fall under 480? Yes. So I don't have to give it to W anymore. Then this results in W being 50. That is the value of W. 50. Okay? So based on this, oh no, there's another page. Okay, so question 5. We have 3 boys going to swim every 8, 14 and 20 days. Then they go and swim on a particular day. This is an LCM question. As long as you rewrite the 3 numbers in terms of prime factors and you start finding the LCM, you get a total of 2 marks. Okay, number 6. Not yet. So she got many cans of Avalon, cereal drinks, and chicken and sons. She wants to divide them equally. This is a HCF question. So as long as you write down all of them in prime factors, you get 1 mark. Finding the common factor. So we see, go down the line, there is only 1, 2 that is common. So write it down. There are 2 3s that are common. So 3 squared. And that gives us 18 hampers altogether. The 5 and the 7, they are not common throughout. Finally, last question. So along comes Nathan. He has 65 bags of rice. The number of hampers is already fixed. We have 18. So we're going to distribute this 65 into the 18 bags. Obviously, 65 is not a multiple of 18. So he can only fill up each hamper with 3 bags of rice. 3 times 18, we get 54. So he has used up 54 bags of rice. The remaining number of bags will be 65 minus 54 is 11. 11 are left over. You cannot divide 11 into 18 different hampers.